Hey students, in this lecture today we are going to discuss based on electric flux and Gauss law, few applications and few numericals is there. Based on them, we are going to discuss numericals. Nana. Today lecture is basically going to be conceptual lecture, Nana, moreover. Okay, if you see the question, you can answer the question if you understand the concept very well. Okay, without making late, let me go to lecture. Okay, let me enter into lecture. So in this first, what we are going to do, Nana, electric flux. We are going to do some problems. Okay, how can you do, miss? They given like this electric field they given, Nana. Okay, so what they given now? So in the question they have mentioned that from here to here some radius they given. Okay, what is the radius value, miss? R they have mentioned. Calculate the flux through curved surface, they told you. How many field lines entering? 1 2 3 4. How many field lines leaving? 1 2 3 4. So clearly we can say that flux total equal to 0, sir, in this case. Why? Because entering number of field lines, entering leaving number of field lines same, na? Entering flux we can take as negative, leaving flux we can take as positive. Net flux how much, na? 0. So flux total equal to 0 if I take. Now what do you mean by that? Flux curved surface means this is circular surface, na? Flux circular surface plus this curved surface, na? Flux through curved surface should be how much, na? 0, sir. Flux through curved equal to how much, na? 0. So if I write here, na, flux through curved equal to what we can write, sir? I know that flux through curved equal to minus of flux through circular we can write, sir. Then how to write flux through circular, na? Minus of. For this face, how can you choose area vector? We can choose outward, because for closed surface area vector, I told you choose the outward direction in the previous lecture. Please watch the previous lecture. A. Okay. A is one direction, E is one direction. How can you calculate flux? E A cos 180. Cos 180 is how much, na? Minus 1, na? So minus of minus going to be what, na? Plus. So minus E into area. Okay, minus is there inside. Inside one more minus 1, na? Minus into minus going to be what? Plus. So let me directly plus we write E into area. Area of this disk is how much, na? Disk surface 4 pi r square, sir. Means flux to curved surface equals to E into 4 pi r square, which we got it, na, in this example. Fine, sir. That's okay. Next, electric field is in this direction. And area vector for this surface I indicated directly. What direction will get it? In this direction will get it. Flux through curved surface, again they're asking here. How to calculate that? Check, Nana. Sir, flux total equal to what you can write, Nana? Flux total equal to 0. Because entering number of field lines, leaving number of field lines 0, equal. Net flux is how much? 0. There is no charge inside. We keep in mind that thing. So what we can do in this case, check, Nana. Flux total equal to what you can write? Flux through curved plus flux through circular, na? So flux through curved, if you want to know what you can write, negative of flux through circular, like this only. Okay, yes, sir. If you observe flux through curved equal to m right, na? Negative of flux through circular, na? What I can write? Minus of EA cos minus theta I should write, na? Okay, otherwise I can write minus EA cos theta directly. Minus what I can write? Minus EA cos theta. I know that students again will ask why minus sign, sir. Think why minus sign I written inside the bracket. EA cos, what we written in this case? Theta we got it, and flux through curved surface. Otherwise E into what we can write, pi r square cos theta and kuda rayachu. Okay, like that we can write it. Why, sir, we written here minus means, so here electric field is in one direction, nana, area vector is another direction. Theta what we got it, that thing we got it. Means theta is opposite direction, area vector. That's why minus theta you choose and solve the problem, nana. Okay, in this case you check 3 field lines entering, 3 field lines are leaving. They place one cylinder here. Flux total equal to much? Sir, flux total equal to 0, sir. Why? Because entering flux equal to leaving flux. Entering flux, leaving flux both are same. One is negative, one is positive. We can take 3 field lines, 3 field lines, sir. Sir, if I place that same thing tilted, sir. Same number of field lines entering, same number of field lines leaving. Sir, total flux I am writing again like 0. Yes, we can write 0, nana. Yes, because how many number of entering field lines, leaving field lines? Entering flux you can take negative, leaving flux you can take as a positive. Okay. In this illustration, what we need to find means a charge Q is placed at the center of a spherical shell. We need to find the flux through that sphere. Nana. How to find that means, so first you choose the electric field. Area vector electric field is like this, Nana. Outward, na, because positive charge. Electric field lines are everywhere outward direction. And how to find the area vector, Nana? Area vector, I told you always extend the radius vector. This is a radius vector, na? This is a radius. I'm going to extend the radius line. That is going to be what, Nana? Area vector. If you observe this, this is area vector, sir. And one more thing, what we can say, Nana? This is electric field, sir. What is the angle between these both? Both are same direction, na? Angle is how much, Nana? Theta equal to 0 degrees. Therefore, flux equals to what in that basic formula? Flux total equal to closed integral EDA cos theta, sir. Cos theta is how much, Nana, in this case? Cos 0, sir. Cos 0 how much, Nana? 1. Because both are same direction. So, flux total equal to what we can write, Nana? E if I take outside, no? Integral dA we can write it. Sir, what is the electric field? This is a point charge at a distance r. Electric field is how much? Kq by r square. Na k means what? 1 by 4 pi epsilon naught. Q by r square. I got it, sir. Here dA. Integral dA means the surface area of the sphere. Nana, how much will you get it, Nana? 4 pi r square. I got it, sir. If you observe, Nana, 4 pi cancel, Nana. R square cancel, Nana. If I place any charge inside surface, Nana, what will you get? You got the Q by epsilon naught. You got it. Sir, if I increase radius to 2r, any change will be there? No change, observe carefully. If I increase radius to 3r, any change? No. It depends only charge inside the surface. That's why flux does not depend on the dimensions. Flux depends on what in this example? When charge is inside, it depends only magnitude of the charge, Nana. Okay? This can be see in this example. If charge inside, na flux contributing, how much charge that? Charge inside by epsilon naught. If charge outside, if I place, no? How many field lines entering in this case? 3 field lines are entering like this. How many field lines are leaving, Nana? 3. This is negative flux, this is positive flux. Due to outside charge, what is the total flux in this surface, Nana? 0, sir. Because leaving flux, entering flux both are same. One is negative, one is positive, which we learned in previous lecture also. Please go and watch it. Due to this charge, electric field is present or not present? Present. Entering, these are electric field only. But due to this charge, outside charge, flux how much? 0. What is meaning we understood? Inside charges only will contribute the flux. Outside charges will be, flux will be much, Nana? 0. But outside charges, inside charges, both will create electric field. Only flux created by what? Inside the surface. That is called Gaussian surface, we can call it as. Let me take one Gaussian surface I took in this example. So what I'm going to do here, for the charge 1, Nana, how to write charge 1 now? Closed integral. Okay, E1 vector dot dA vector. Electric field due to 1 dA equal to what you can write, Nana? Charge 1 is inside the Gaussian surface, na? Yes, sir. What you can write? Just now we proved that charge by epsilon naught, Q1 by epsilon naught. Closed integral E2 vector dot dA vector. Charge is inside or outside, Nana? E vector dot dA vector you take if you want. Charge is inside, outside, outside. Just now you I proved in previous example. Due to that field, electric field will be there. Check here. Electric field lines will be there, but flux how much, Nana? 0. Electric field will be there, charge is 0, that's why flux also 0. What is it, Nana? 0. Closed integral E3 vector dot dA vector. Due to third charge. Due to third charge, electric field is there, will not be there. Will be there, third charge. But inside the Gaussian surface, na, flux also will be there. Therefore, how much is flux? Charge by epsilon naught, sir. Q3, na? Yes, sir. Q3 by epsilon naught, which we can write it in this case. Next question. Here, what is there? Fourth charge inside only, na? Therefore, it creates electric field as well as flux. E vector dot dA vector is equal to what I write, Nana? Minus Q4 by epsilon naught. Charge is a scalar quantity, along with the sign we should take it, Nana. Flux also scalar, in fact. So flux equals to, due to which one, Nana? Fifth charge. Check where is fifth charge. Fifth charge is out of the surface, sir. So E5, electric field due to 5 will be there. dA vector, but that is outside the surface, na? Through the surface flux how much, Nana? 0. I showed you just now in the before examples. 0. So total flux, what we can write in this example, see, Nana? Sir, total flux, what you can write, Nana? Due to all the surfaces, flux you want to write, na? Sir, I can write like this, total flux. How can you write, check, Nana? So, I can write simply, closed integral, E vector dot dA vector is equal to what you can write, Nana? This fellow summation. What I can write? Q1 plus Q3 minus Q4 into 1 by epsilon naught. I just took the, in all of them, epsilon naught I took common. This Q1, Q3, Q4 is what, Nana? Inside the charges, charge enclosed by the surface. So flux through any body is depends only charges inside. But electric field develops due to what? Inside charges also, outside charges also. Very important point, keep in mind, Nana. Look at this. This is only we are going to set the like a Gauss law, Nana. Gauss law states that the electric flux through any closed surface, like this surface, is equal to the charge enclosed by the permittivity. Okay? Charge enclosed by permittivity is called what, Nana? Flux. How much charge enclosed in this old example? Q1, Q3 minus Q4. So flux contribution is only this much will do, Nana. Okay. Let me conclude that point here. Closed integral E vector dot dA vector equals to Q epsilon naught by Q enclosed by epsilon naught, generalized form of Gauss law. Here they will ask you on MCQ, how they will ask you, just check here. E vector dot dA vector, electric field due to how many charges? I just showed you before example, refer that. Electric field due to all the charges developed. So here electric field is due to what, Nana? All the charges, whether inside or outside. But electric flux is due to what, Nana? Only inside charges, enclosed charges. Okay, fine. Let me see one previous year question of AIMS, what they asked you, 2012 question. One very good conceptual question. If you did not understood before theory, you may not do this question, Nana. So what is the question? Let me see here, Nana. What is the question? 4 point charges Q1, Q2, Q3 and Q4 are shown in the figure. The flux over the shown Gaussian surfaces depends only on charges q1 and q2. So ఇక్కడ q1 ఇది q2 nana మీకు observe, if you not see visible now, this is q1, this is q2, this is q3, this is q4 ra. So q1 and q2 only inside the Gaussian surface. That's why flux due to only what depends nana, flux due to the surface depends on q1 and q2. So assertion is true or false nana? Assertion is true nana. False. Reason you see, what is the reason they given? Electric field at all the points on Gaussian surface depends only on the charges q1 and q2 na. No electric field due to which one? Due to this field also created like this. So two field lines entering, two field lines are leaving. Flux how much? Due to this field how much? 0. Okay, flux due to only inside charges, but field due to what? All the charges. But due to outside charge, flux will become 0 na. That's why electric field at all the points on the Gaussian surface depends only on the charges q1 and q2. True or false? True nana. Electric field due to all the charges will come na. False nana. This is okay, it's not true. False nana. So statement 1 is true nana, statement 2 is false nana. So if assertion is correct or reason is incorrect nana, AIMS question. Very good conceptual knowledge required for this question. Please go through once again carefully. Fine sir, if we go to next example. So this example is based on EAMCET taken again nana. They can ask you in NEET exam also, they can ask you in EAMCET exam also, they can ask you in KCET to JEE also. A charge q is placed inside the cylinder. NCET example similar question is there, please go and check. Through this curved surface flux how much nana? 5. Okay, through curved surface flux is 5 means what they are asking, here we are having two flat surfaces now. How many flat surfaces? This is first fellow, this is second fellow, these both are flat. This is curved surface, feel like your water bottle, side face, curved surface. So flux total equal to what you can write nana? Charge inside is there na, that's why what you can write? Q by epsilon naught. But flux due to how many charges nana? Sir, how many faces nana? 3 faces. Flux due to this face, flux due to this face, flux due to this face. So flux to flat surface, one is flat surface, plus flux due to this flat surface, both are identical nana, plus flux due to this curved surface nana. Flux due to curved surface is equal to what you can write nana? Sir, q by epsilon naught I can write it sir. Yes nana, q by epsilon naught correct only. But flux due to curved surface they given 5 na. So flux two flat surfaces, flux equal to plus flux due to curved how much nana? 5 is equal to what nana? Q by 2 epsilon naught. Send this flux this side nana. So flux due to two flat surface equal to what nana? Q by epsilon naught minus 5. They are asking flux to flat only. So flux to flat means what you can do it nana? Flux to flat surface equal to, you send that to that side nana, what will happen now? 1 by 2 times the q by epsilon naught times the minus 5 nana. So here we have done one mistake, please correct it nana. So what we have done here, plus 5 means here also plus 5, how come we will get it? If plus goes RHS side na, minus 5 will get it. So this is the answer for this question nana. Very good question, decent question, practice this question once again. Fine, we'll go to next question. They given 3 different surfaces they given. This is cube, this is cylinder, this is charge nana. What is this? Sphere. Flux through each body they're asking. Here charge includes how much nana? Q. So flux due to Q equal to how much nana? Q by epsilon naught. Sorry, it does not depend on dimensions of body. Earlier only we concluded. Through cylinder charge Q only substituted. Flux equal to what will happen nana? Q by epsilon naught. To this will how much nana? Flux equals to Q by epsilon naught. So flux due to all the surfaces what nana? Same. It is independent of shape and size nana. It is one of the NCET exemplar question which is most important for our NEET to JEE and or EAMCET to KCET also nana. Okay, for KCET NCET exemplars are most important questions. Similar question is there NCET exemplar, check. That's why given conclusion point, note electric flux through a closed surface is independent of the size and shape. Whatever the size, whatever the shape, flux will be same. Sir, if I increase if side length is a, if I take here, if I take 2a, does not depend on dimensions, no, flux remains same. Sir, if radius is there, if I take radius 2r, does not depend on dimensions, does not depend on the size. It depends only on the charge enclosed in this case. Fine sir. Here one charge q is there na. What is the flux through the total cube they are asking nana? Flux through total cube is how much nana? A charge is completely enclosed na. Q by epsilon naught I can write it sir. Flux through this face how much sir? This charge is placed symmetrically at the center. Flux through in all the faces should be equal. Flux through each face how much nana? Through through entire cube, q by 6 epsilon naught. But how many faces is there? 6 face na? 1, 2, 3, 4, back to front. So what do you write? Flux through each face equal to what you can write nana? Flux through each face is q by 6 epsilon naught, which we can write it nana. Fine, we'll go to next slide. Yes nana, in these illustrations what they given, these are illustrations which is there in JEE and HCV also. Here one charge they placed here on the surface they placed, here outside they placed. If charge is placed inside the surface and completely closed, what is meant by flux here nana? Flux equals to what you getting nana? Here q by epsilon naught sir. If charge is placed on the surface, what will get nana? Flux equals to Q by epsilon naught. If you write now, that is wrong. Why? Because charge is closed or not closed? Not closed. Then what I have to do, sir? You should take one similar surface and try to close it nana by symmetry. You close it by taking similar body. Then flux close it, flux to passing through one body or two body? Sir, two bodies, sir. Therefore, flux equal to what is written through this body? Through one body, both bodies Q by epsilon naught. One body what will get? Q by 2 epsilon naught. Okay? Sir, if they place charge outside, sir, flux equal to much nana? 0. This question they asked in JEE nana. Recent JEE 2023 or 24, you please go and check. In that between those two chart only. Here they took one cone, here they placed the charge Q. What is the flux is there or not there? It is on the surface na. Take one similar surface and close it nana. Symmetry should be there nana. Similar surface I took it, I close it that nana. If you close na, flux is sharing through two bodies. Now you want flux through what nana? One body, sir. Flux through single body is much sharing by two bodies na. Due to one body what will get nana? Q by 2 epsilon naught. It's similar like one apple shared by two friends. Okay, fine. Here they given na, this thing is HC Verma question nana. They given a cylinder nana. Charge Q they placed here. What is the flux through that face are asking? If it is closed na, no flux outside means it is not closed na. Take one similar body and close this. If you take similar body and close this, now what will happen? Tell me nana in this case. Flux is shared by two similar bodies. So flux total equal to what will get Q by epsilon naught, but flux through this face alone I want. This body only. I'll get Q by 2 epsilon naught, sir. Sir, if I place like this, sir, what will happen, sir? Example. What we can do in this example, you see, charge at the top of a square they placed at what distance? A by 2. Sir, where did you found this question? Means this question is there in HC Verma, this question is there in NCRT, this question is there in JEE. Go and please check. Okay, fine. Charge is open or closed? Open surface. Now charge is not closed. If it is closed outside, now flux is 0. Then what you do? Go at a distance A by 2. Take one sheet like this. Now one square sheet like this you take. Closed? No. Take left side one similar sheet like this. By symmetry, not closed. Take this side nana, not closed. Because front and back not closed. Front also you take one sheet nana, not closed. Back also you take one sheet nana, closed. Now it is looks like a cube. Charge is at the center. Flux through what they are asking? Flux through this only square sheet. This will become flux total equal to how much nana? Q by epsilon naught na. Flux due to this face is how much nana? Q by 6 epsilon naught, sir. So here diagram not become good. That's why I am going to present one more diagram for this. If they given question like this, on square side they given A nana. At a distance A by 2 they place the charge Q. So this if you take the square A, if you place the charge at center, both look same only. Look at that. Yes, sir. Then they want flux through due to this one face. Square sheet is nothing but one face na. Flux due to one face equal to much nana. Flux due to one face equal to Q by 6 epsilon naught. This is previous JEE mains question which is there in HC Verma, which is there in NCET also. Please go and check nana carefully. Okay, sir. For example, if they place charge at the face, sir. If they place charge at the face now, take one similar cube and place on it nana. If you place on it, flux how much nana? Sir, two similar bodies shared, sir. So through one body how much flux now? Two bodies shared now. Total is Q by epsilon naught. Two bodies means what will get nana? Through one body flux equal to Q by 2 epsilon naught, which will get it in this example. Then we go to this example nana. Here one charge is placed here na at the edge nana. So very good question this is. Okay. How to solve this question? Let me see. I should enclose this charge because it is on the sphere. Outside the cube means flux is 0. How can you enclose? I am taking here one cube, identical cube. I am placing nana at this side. Sir, closed. Closed or not check nana? No, sir. Only below half closed. To close above half, what you have to do? Take two more cubes like this. Place on this. Yes, sir. I am trying to place on that fellow carefully by symmetrically. Now charge is exactly at the center of these four cubes. So flux equals to much due to all this system Q by epsilon naught. Due to alone this one system shared similar bodies 4 na. So flux equals what again na? Q by 4 epsilon naught. Means if any charge is placed at the cube side no, flux equals to Q by 4 epsilon naught will get it nana. Fine. If you have charge at the one face nana, charge is placed at where nana? One corner they placed. How to find the flux? How to find the flux means you check nana. You take one similar body, you place one side nana. If you place one side, a charge is closed. Check here. You placed here. No, sir. You place in front of this nana here. Like otherwise, you place here nana. Is it closed? No, sir. You place one more cube like this. Closed? Sir. Closed, sir. No, nana. We are doing wrong. It's not closed. Only base part only covered for the charge. Half of the part only covered for the charge. Not remaining half. So far we took 4 cubes but still not closed. Then what I have to do, sir? Take 4 more cubes, similar cubes. I'm taking 4 more similar cubes. Exactly, I'm placing on top of that 4 cubes like this. Observe, don't get confused in the diagram. Such a beautifully designed diagram. Okay, it took for me to 5 minutes to draw this many cubes. Yes, sir. Now 8 cubes is there. Front 4, back 4. On these all 8 cubes, charge is placed at exactly at the center. Flux through all of them is same. Flux total through all the 8 cube is q by epsilon naught. Through 1 cube is how much, nana? So through 1 cube, what do you write, nana? Flux through 1 cube equal to q by 8 epsilon naught. Means if I place any charge at the edge, flux through that cube is how much, nana? Q by 8 epsilon naught, you will get it, nana. So if you observe here, I given like this. If charge is q here, flux through this entire cube is how much, nana? Q by 8 epsilon naught. If anybody asks you, 1 second, I'm writing 8 here. Flux equals to what you write, nana? Q by 8 epsilon naught. Before example only I told you. If they ask you about any phase, nana, here a little difficulty will come. You may attempt the wrong also. Simply generally what will tell, if charge is q, sir, flux equals q by epsilon naught, na? Through one phase, if they ask you this phase, sir, how to calculate flux through one phase equal to total by 6 phases, na? So what will get to q by 8 epsilon naught into 1 by 6 epsilon naught. Okay, 8 6 is 42, q by 42 epsilon naught, sir. So what is wrong in this, sir? Perfectly wrong answer, nana. Okay, first I taught you what is the wrong answer, how student will make mistake I given. Why wrong answer? Let me check here. Why wrong answer you check here? Why wrong answer means flux total is how much, q by 8 epsilon naught, na? Okay. Here charge I place, na? For this charge I am drawing few electric field lines. Some electric field lines going on the surface like this. On this side surface some electric field lines passing like this. On back surface also or electric field lines, some electric field lines going like this. If you check in this example, na, area vector for this surface, na, perpendicular. Means flux is equal to how much? Angle 90, na? Flux equals to EA cos 90. Through this face, how much, nana? Flux 0 degrees, sir. Through this surface, you check, nana? Angle 90 with the electric field. Electric field like this, area vector like this. Angle 90. Flux equals to how much? 0. Because EA cos 90 0. Through back surface, how much, nana? Area vector outward, na? Like this. Angle how much, nana? 90. Okay. Actually, you should draw back side. Okay. Don't get confused about that. Since you cannot see, na, that's why I driven forward. So flux equals to how much again? 90. This point already we discussed in last lecture, nana. Please go and check. Whenever electric field lines are passing on the surface, no, through that surface flux equals to how much? 0. So due to this top one, no, due to this side one, no, due to back side one, flux equal to 0. Then remaining is what? This fellow, front fellow, bottom fellow only. That's why whatever the q by 8 epsilon through entire cube is there, no, not shared by 6 phases. Shared by 6 phases. Shared by 6 phases, 3 phases, 3 phases only, sir. So q by 8 epsilon naught into what we can write, 1 by 3 only. So flux equals to what we get, flux through one phase equal to what we can write, q by 24 epsilon naught. Flux through this phase. For example, in the examination, flux through this phase, if they ask you 0, flux through top phase 0, flux through back phase 0. So don't worry about that, nana. Please see carefully. Okay, this thing, if they can ask you like this also, if I'm having one square sheet at a distance A from the top of an edge, if they place charge q, no, it's same way. Flux through entire cube, if they ask you what they can write, q by 8 epsilon naught. But they want flux through this sheet, na? Flux through this sheet means what will happen now? Flux through this one we need. Flux through this one, what we can write, na? Through one phase, na? Earlier question only. Flux equals to what we can write, na? Flux equals to q by 24 epsilon naught, sir. Just now we solved. Yes, nana. That is only answer for this, sir. Now I am going to conclude all the points once, nana. One charge placed at the center, one charge placed on the face, one charge placed at the edge, one charge placed at the corner. Flux due to all the charges they asked you. Flux is a scalar, na? Directly calculate. Flux total equal to. If I place charge at the center, na, flux equals to by symmetry q by epsilon naught, sir. If I place on the face, na, I got it like q by 2 epsilon naught, sir. Okay, but that is 2q, na, 2q by 2 epsilon naught, sir. If I place at the edge, na, q by 4 epsilon naught, sir, but charge is how much? 4q. 4q by 4 epsilon naught. If I place at the edge, just now at the corner, just now we did, nana. What we got, 16q by what we get, nana? Yes, sir, 16q by 8 epsilon naught, sir. If you observe carefully, nana, 2 2 will get cancelled, 4 4 will get cancelled, 8 1 ja, 8 2 ja. Therefore, flux total equal to what will get, nana? Q plus q, 2q plus 3q, 3q plus 2q, 5q. 5q by epsilon naught, nana. Sir, can I write the SI unit? Write volt into meter or Newton meter square per coulomb. Any unit you write it. So like this, if they give multiple charges also, we can calculate this, nana. Fine, if you observe carefully, linear charge density we are going to study. What is linear charge density? Charge per unit length. For example, I am having a rod here. On this rod, you are distributing the charge, nana. Some charge you distributed like this, nana. Okay. and through what length nana L, what charge nana Q charge. Now how can you define lambda, one dimensional thing na, lambda equal to linear charge density charge by length. Okay, lambda equal to Q by L. How can you write SI unit? Q is SI unit is what? Coulomb na, length meter, coulomb per meter. CGS unit what you can write na? Electrostatic unit we can write coulomb as CGS unit. Electrostatic unit divided by static coulomb we can call it as. Okay, divided by what you write na, centimeter, dimension formula. And top of that what is there na? Charge na, charge is dimension formula is what? A power 1 T power 1. Below na length. So if I take length to numerator na, L power minus 1 T power 1 A power 1 na. And sir, if they given lambda, how to calculate charge in any surface? Lambda equals to charge by L means charge equal to what you can write? Charge inside the surface. Lambda into L we can write it na. Based on this also, one or two applications I am going to show you. One infinite wire is there. Lambda equal to 5 coulomb per meter. Okay, they took a one Gaussian surface. Which Gaussian surface in this cylindrical they took? This is what na? Gaussian surface they took na. In this Gaussian surface, what is the flux coming out? They're asking. Means how much charge inside you need to calculate now. How to calculate charge inside na? Just now I told you, right? Q in equal to what I told you. That much length into linear charge density. Lambda into what I write na? L. So Q in equal to lambda value what they give in the question 5. How much charge enclosed? This much length charge, how much is that? 2 meters. So what you get na? Q in equal to what you get na? 10 coulomb I got it, sir. So flux total equal to what you can write in this case? Flux total equal to what you can write na? Q in by epsilon naught, sir. Q in by epsilon naught. So flux total equal to what is the Q in value in this case? 10 coulomb by epsilon naught, which we can write it na. This similar question I think they asked in AIMS exam or NEET exam, I don't know. Medical entrance only they asked you. Check it carefully. Okay, very good question. So let me take one more similar example. One sphere is there. Through that sphere, they sent the rod here, lambda coulomb per meter. Calculate the flux through that Gaussian surface. They're asking. Flux means what you have to find out. How much charge is there? You should find out. How much charge means how to write Q in is equal to. Let us assume this distance is x. I assume this distance r by 2 they given. I assume this is x. If this is x means by symmetry this is also what x. X plus x how much 2x. So lambda into 2x I can write. Your task is to find the x. How to find that? This is x, this is r by 2, this is perpendicular na, like this we can write it. What I can write this is hypotenuse na. So opposite side square equal to hypotenuse square. X square plus r by 2 whole square is equal to r square I can write. Yes sir. So x square equal to what I can write r square minus r square by 4 sir. Yes na, x equal to what I can write 4 r square minus r square 3 r square na, root 3 into r by 2 I got it sir. This is x but 2x we need to substitute. So Q in equal to how much charge is there? This much length only enclosed na, that much charge only enclosed. So lambda into 2x. 2x is how much na? X is how much? 2 into root 3 r by 2. 2 will get a cancel. Q in is equal to lambda into root 3 r, which we got it na. Fine sir. Then how to calculate flux? Over flux total equal to what we get na? Flux total equal to Q in by epsilon naught sir. How much charge enclosed? Just now we calculated. Flux total equal to lambda into root 3 r by epsilon naught. Very good JEE level question nana. Based on HC Verma we created one sum here. Okay, please solve the problem carefully. Until you are not practicing, you will not get this kind of questions. You should take pen and paper and you should solve nana. Okay, so fine. In this lecture we have discussed about the how to calculate the electric flux by using Gauss law and electric flux formula also. Okay, we have done very good illustrations for your JEE level, NEET level, EAMCET level and the KCET level. Please go and practice them very well. And if you like the video, okay, please like the button and hit the bell icon, subscribe the channel and share to your friends such that it will be useful for them also. Okay, bye dears, take care nana.